Greetings. Welcome to Unit 4's third topic, Exponents and Division. Okay, before we do this, I want to remember, we said yesterday that when you're not sure about exponent problems, when in doubt, write it out. That's going to come up a bunch in this lesson. Just remember, when in doubt, write it out, and you should be able to get the problem correct. Even if you don't remember the tricks or the rules or the strategies, you can always write it out and solve a problem correctly. Alright, here's an example. What if you have x to the sixth divided by x squared? And this is a division problem because aren't fractions usually top divided by bottom? Yeah. So this is a division problem, and we have to decide if you have x to the sixth over x squared or x to the sixth divided by x squared, how many x's are we going to have left? Well, when in doubt, write it out. So x to the sixth is x times x times x times x times x times x. X squared on the bottom is x times x. And if you notice here, you've got an x there that's going to cancel with an x there, right? Just like reducing a fraction, you can scratch out things. So what we have left is x to the fourth on top and nothing on the bottom, so we put a 1 there. But we don't even really need that denominator. We can just say that the answer to this problem is x to the fourth. You might notice we started with x to the sixth and x squared, and the 6 and the 2 ended up giving us a 4. So if you were thinking that you're able to just take a little shortcut here by just doing top exponent minus bottom exponent, you're correct. The rule is top exponent minus bottom exponent. That's why we had 6 minus 2, which gave us an answer of x to the fourth. If you don't remember that, fine. When in doubt, what should you do? Write it out. All right, let's look at another example. Let's say you had z to the 14th over z 7th. All right, I don't want to write 14 z's on top and 7 z's on the bottom, so I'm just going to use the rule, and the rule says top exponent minus bottom exponent, so 14 minus 7 is 7. I've got z to the 7th, and that was really quick and easy. Okay, what if I have a to the 30th over z to the 12th? Well, that's not going to work. Okay, a's and z's, you can't do anything with a's and z's. The base numbers have to match for you to do any trick with the exponent, so get rid of that. But, if you have more than one thing there, like x cubed y squared, x squared y, we can still do this. We just have to treat the x's separately and the y's separately. This is going to turn out to xy over 1, and here's how. When in doubt, write it all out. So I've got x, 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 y, y on the top. I've got x, x, y on the bottom. I'm scratching, I'm scratching, I'm scratching, and look what I have left, an xy. It's as easy as that. Okay, do you even really need to memorize any rules on this? No, all you need to remember is when in doubt, write it out. Of course, if you remember the subtraction rule, you look at the x's, and there's a 3 and a 2 for your exponents, and 3 minus 2 is 1, and that's why it's x to the first, which is just x. And with the y's, you've got a 2 and an invisible 1. That's why you get 2 minus 1, which is a 1, and it's y to the first as well. Anyways, when in doubt, write it out if that's too confusing. All right, let's see if you got it. Try this one, and try this one. Pause it if you need to, or come back to this after the end of the video, but make sure you finish those practice problems in your journal. Okay, here we go. This should be easy. We remember the rule is top exponent minus bottom exponent, right? So 2 minus 6 should give us x to the negative fourth. Is it possible? Well, I guess 2 minus 6 is negative 4. That seems a little weird to have a negative exponent. Oh yeah, let's when in doubt write it out and see what that actually means. Okay, we know we started with x squared over x to the 6th. We know we ended up with x to the negative 4th. Here's the in-between step. X on top, x on the bottom. Match, scratch, match, scratch. You've got nothing on the top and 4 x's on the bottom. We would write that like 1 over x to the 4th, wouldn't we? Yeah, I think so. So x to the negative 4 power really means 1 over x to the 4th. Interesting. The rule is negative exponents go in the denominator. So if you have like a number like 8 to the negative 2 power, it means you're going to do 8 squared. You're going to do 8 to the 2nd power, but you're going to do it in the denominator. Or if you had 10 to the negative 3, you're going to do 10 times 10 times 10, but where are you going to do it? In the denominator. Okay, that's not too bad. You just kind of have to memorize, what do negative exponents actually mean? They mean the power happens in the denominator, and you put a 1 in the top just to be a placeholder. So try this one. If you had 7 to the negative 2 power, what would that come out to? All right, one more thing. What if they match? What if you have x12 over x12 and you do 12 minus 12, right? And you get 0. Are you, again, allowed to have a 0 as an exponent? Yes, you're allowed to have 0 as an exponent, but let's see what this means. Look at the original problem, x to the 12th divided by itself, isn't it? Isn't anything divided by itself 1? Like 5 divided by 5 is 1, and 10 divided by 10 is 1, and 11 divided by 11 is 1. So wouldn't x to the 12th divided by x to the 12th be 1? Why, yes, it would. The rule here is x to the 0 power always equals 1, and since x is a variable, it can mean anything to the 0 power always equals 1. Repeat it with me. Anything to the 0 power always equals, that's right, 1. So what's 8 to the 0 power? 1. What's 11 to the 0 power? 1. What's 2.3 to the 0 power? 1. Anything to the 0 power always equals 1. 119 to the 0 power is 1. And 1 to the 0 power is 1, because anything to the 0 power always equals 1. So, evaluate this, please. See you tomorrow.